Now we come to IGCSE 2023, October and November, Additional Mathematics, Paper 1, Set 1, question number 9. So this time is about series, that topic. So for part A, we have an arithmetic progression, AP. So how about that? We call some formula about AP, which is the common difference D should be AN plus 1 minus AN. So maybe we can use A2 minus A1 or A3 minus A2. And then for the nth term, it is equal to A, which is the first term, plus bracket n minus 1 times the common difference. So now let's see what we have got. For the first three terms, they are negative 3 tangent theta over 2, negative tangent theta over 2, and tangent theta over 2. We also have the 12th term. It is equal to 19 square root 3 over 3. We need to find the value of theta. So now let's just identify something. How about A? The first term must be negative 3 tangent theta over 2. How about common difference D? I use A2 minus A1 here. So A2 minus A1, I will have this. Simplify it, I will get positive 2 tangent theta over 2. And then we can make use of this for the nth term using this formula. I will have for the 12th term, it will be the A, the red one, plus n minus 2, where n is 12, times the blue one, which is the common difference. But for this number, it is just equal to 19 square root 3 over 3, so we can just substitute it inside. And then for the right-hand side, just simplify it. And for negative 3 plus 22, we have 19 tangent theta over 2 on the right-hand side, and then divide 19 to the left-hand side. We will have this equation. And now maybe you can use your memory. Actually, tangent 30 degrees must be equal to this, or square root 3 over 3. But if you forget it in the exam, maybe you can also use your calculator to press shift tangent square root 3 over 3, and you will have the answer 30 degrees. But we want to have radian units, so you need to change it back into pi over 6. So here I will have these two values. Oh, why two values? Positive tangent, we should also think about the quadrant 3, which is pi plus pi over 6. If you are not sure if it is correct or not, just write it down first and then simplify these two. But for the final answer, you need to check. The theta is pi over 3, one answer. And the other one, if you simplify it, you will have 7 pi over 3. But 7 pi over 3 should be larger than pi over 2, so it is rejected. So we just got one value of theta, which is theta over 3. Now we come to part A2 of this AP. We need to find the exact value of the sum to 10 terms of this progression. So let's recall some formula. We need to use this sum to n terms, which is 1 over 2 times n times bracket a plus l, whereas l is the last term. And in part 1, we already know that theta must be pi over 3, and a should be negative 3 times tangent pi over 6, while d, the common difference, is 2 times tangent pi over 6. So now we can make use of this to find first the 10 terms. It is equal to the a plus bracket 10 minus 1 times the common difference, and then simplify this, we will have something like this. So negative 3 plus 18, we will have the 10th term should be 15 tangent pi over 6. And now we can make use of the sum to nth terms. Just substitute all the thing, right? Whereas n is 10, and then the first term, and then the last term, 15 tangent pi over 6. Add them up, you get 12 tangent pi over 6. For 5 times 12, you get 60. Or tangent pi over 6, it is equal to square root 3 over 3. Remember, we need to use the exact value, but not using the calculator. So here, just simplify them. You will have 20 square root 3. That's it for part 2. Now we come to part B. We need to find something about a geometric progression, GP. So let's recall some formula about them. For a common ratio, it is equal to an plus 1 divided by an. For example, a2 divided by a1 or a3 divided by a2. And then for the nth term of a GP, it is equal to a, the first term, times the common ratio r to the power n minus 1. Remember, it's n minus 1 power, but not just n. This GP is made of the first one, 1 over 16, cosecant phi to the power 4, and then 1 over 4 cosecant phi to the power 2, and then the third term 1, which is a good number, just an integer. And then we also know that for the sum of the third term and the fourth terms, just 2 terms, is equal to 4. We need to find the possible values of phi. So maybe we have more than one values of phi. So let's begin with identifying a and r first. So for a is just the first one, but I will here make it into from cosecant to sine, because later on maybe we need to solve some trigonometric equation. So I will make it of sine instead of cosecant. So it will be 1 over secant phi to the power 4. So how about the common ratio? For the common ratio, I will use the third one divided by the second one. Will be here, 1 divided by this whole thing. And similarly, I will make this into sine, which is 1 over sine phi to the power 2. And for these two fractions, or multiply them, it's just 1 over 4 sine square phi. And then for 1 divided by this fraction, it will just give you 4 sine square phi. So now we have a and r. So how about the third term and the fourth term? Oh, come on. The third term is just 1. So just write 1. So how about the fourth term? It should be the third term times the r common ratio, because the common ratio is 4 sine square phi. So the fourth term is just 4 sine square phi. So now we can add these two up. They will be equal to 4. So we have one trigonometric equation. So just solve this one. Also minus 1, you get 3 in the right hand side, and then divided by 4. Remember, it's a quadratic one, so we should have two values of sine phi. So for sine phi, it can be positive square root 3 over 2 or negative square root 3 over 2. So for positive square root 3 over 2, if you remember it, actually it's just equal to 60 degrees. But if you don't remember, you can just press calculator and you'll get 60 degrees. But again, we need to make it into radian units. For the red one, you have two values, which is pi over 3, which is 60 degrees, or we can also think of the quadrant 2, which is pi minus pi over 3, which is 2 pi over 3. But here for 2 pi over 3, it is larger than pi over 2, so it is rejected. So how about for the blue one? For negative square root 3 over 2, you should get it negative 60 degrees with your calculator. So it's just negative pi over 3, and the other values should be the third quadrant, which is pi plus pi over 3. But this again is larger than the range here, pi over 2, so it is also rejected. So we just got only two values of phi, which is phi can be pi over 3 or negative pi over 3. Now for part B2, we need to determine whether or not this progression has a sum to infinity. So let's recall the formula of sum to infinity is a divided by 1 minus r. But very important, absolute values of r must be less than 1, which means r can be in between 0 to 1 or in between 0 to negative 1. So but what is the value of r here? We just find it and we can determine. So before we find this r, we need to make sure we know the values of phi, where we have done in part 1, it is pi over 3 or negative pi over 3. So we just substitute these two values. Remember, both of them should be substituted. So now we got r can be 4 sine square pi over 3 or 4 sine square negative pi over 3. So here, for sine pi over 3, it is equal to square root 3 over 2. and all square, you will have 3 over 2. But for sine negative pi over 3, you will have negative square root 3 over 2. But after squaring it, you still got 3 over 4. So anyway, you get the same value of r, which is 3. It must be 3 for either case. So r must be more than 1. Absolute value of r must be less than 1. So for both cases, we cannot have a sum to infinity here. That's it for question number 9. Thank you.